All right, claim evidence and reasoning. So the basis of science is asking questions about the world around us. Those questions often lead to investigations or experiments and research. In class, you will see things that make you curious about the natural world. We call these things that make us curious phenomena. You will ask lots of questions about phenomena this year, and some of those questions will lead us to do an investigation to answer that question. We will make observations and collect data, but once the investigation is complete, what do we do with that information? How do we make sense of it? Well, that's where CER, or claim evidence and reasoning, comes in. So claim, remember, we're asking a question. So the claim is a statement that answers the question. It's usually just one sentence long. So pretty simple there. The evidence is scientific data that supports or agrees with our claim. Okay, so you do a lab, you probably have some type of data table, you might have numbers or observations that you made during the lab, and that is your evidence that you're going to rewrite for your claim evidence and reasoning. Okay, and then the last part is the reasoning. This is just an explanation that describes why the evidence supports or agrees with the claim. Okay, and this is usually the more tricky part, but we'll be practicing it a lot from now through the end of the year. So it's really something that you want to listen into right now and get the learning in now to benefit you along the way. So in that reasoning, we're going to use some type of scientific definition, like maybe it's the definition of photosynthesis, okay, or a principle, like a theory, the theory of evolution, or maybe it's a law, the law of gravity, okay? So there needs to be some scientific basis that you're basing your information off of, right? It needs to come from a credible source. So you'll state the source of where the information comes from. It might be from a website like a .org or a .edu. We'll stay away from .coms and .net because anyone can make those sites. Or maybe it's from a scientific research article, okay? Or maybe it's from your biology notes. You can take those as credible as well. Okay, so let's get into an example. Like I said, in class, I'm going to give you some type of phenomena, some crazy thing that makes you kind of curious, makes you want to ask some questions. Let's say that I show you steel wool being lit on fire. And I say, all right, come up with a bunch of questions that you have about this, okay? And maybe we have a huge list. Maybe we have 50 to 100 questions written down. We're going to look at those questions. We're going to determine, okay, which of these questions can we just easily Google, figure out the answers to? Which ones could we do an investigation based off of? Okay, so we'll kind of sort through those questions. But initially, you're just going to question vomit everything that comes to mind. Okay, it's a really good quality to have, to look at things and be curious. Okay, so let's say that we sort through those questions and we really like the question that someone came up with, and it says, what happens to the mass of steel wool after it's lit on fire? Sounds like we could try that. So then we do an investigation. We do a lab to figure out the answer. And just in a moment here, I'm going to show you an example of that lab. Okay, so take a look. Watch the numbers on the scale, 27.37. Okay, watch what's happening now. Okay, and we're going to wait until the fire is completely out to see what the end mass will be. Okay, still a little bit of a flame. All right, 29.11. Okay, so let's say that was our lab. You wrote all of that information down in your data table in your lab. Okay, so now we're going to come up with a CER. Here's our original question. What happens to the mass of steel wool after it is lit on fire? Okay, now my claim is just an answer to that question. The mass of steel wool increases after being lit on fire. Okay, now I'm going to give you all a CER checklist to help you go through and make sure that you include everything you need. So for your claim, it's super simple, states the answer to the question in 1 to 2 sentences. I did that, so we're good. Evidence, okay? The starting mass of the steel wool was 27.37 grams, and the ending mass was 29.11 grams. And that is from data table number 1 in my lab packet. Okay, let's look at our checklist. Includes information that supports the claim. Okay, does the information in my evidence agree with my claim? Okay, steel wool increases. My evidence shows an increase. I'm good there. Okay. Next, states actual numbers when appropriate. I did, and it was appropriate. States observations when appropriate. This would be if we did a lab that we weren't collecting numerical data on. Okay, so I don't really have anything I need to add there. States where the data or information came from. I did that here in parentheses, that it's from data table number 1. And does not explain any information yet. Yeah, I just was super straight and to the point. Here's my data. This is where it comes from. And that's your evidence. So those first 2, super simple. Let's move on. Okay, let's look at some reasoning. So what happens to the mass of steel wool after it is lit on fire? Now, I would probably have to do some research to figure out what actually went on there. So let's say I did that and I come up with my own reasoning in my own words. Steel wool is made of strands of iron. The chemical symbol is Fe. Okay, and it's loosely bundled together. When iron is heated, it reacts with oxygen in the air to form iron oxide. This is a combustion reaction because the steel wool reacted with oxygen. The equation for this reaction is 4Fe plus 3O2, blah, blah, blah. The addition of oxygen from the air accounts for the increase in mass. Okay, so we're adding oxygen to iron. Okay, the steel wool went from iron to iron oxide, which is a larger compound with more mass. Okay, and then I list my sources. I got some stuff from my biology notes. The rest of it was from the University of Washington, which is a .edu. Okay, now let's look at our checklist. Okay, did I use a scientific definition? Well, if I kind of sift through this, combustion would have been probably a term in my notes. Okay, so I have a definition there. Okay, I also, you could say, this equation is, it's not a definition, but it's kind of like a scientific principle. Okay, so I have some stuff to back up what I'm saying. So that's good. States the source of the information. I did that. I got some stuff from my notes and from here. Makes connections between the evidence and claim. Okay, so my claim stated that we had an increase in mass. I definitely talked about that here, okay? And my evidence showed an increase in mass, so I did connect to that. The explanation goes in depth to fully explain the science concept and the answer to the original question. I would say for this topic, this is pretty in depth, okay? For some topics, you're going to end up with a lot more information. And for some topics, you might have a little less. It just depends how much information is there to talk about. Okay, so I'd say this is good. One more thing before we move on. Okay, let's say I did this lab and something happened and I ended up getting results that I would not expect. Okay, this is going to happen. It happens to scientists. It's going to happen to you in class where you do a lab and you get the results that don't make sense because there was some type of error, and that's okay. Let's say I did that. Let's say my data doesn't make sense with what sources online tell me. Okay, what you're going to do, you're going to have this tip here that you're going to follow. So if your lab data does not match what we would expect to see based on previous scientific research, you'll do the following. Your claim. You're going to make your claim as normal based on your data. Okay, so if my data shows a decrease in mass, I'm going to make my claim. Mass decreased. I'm going to list my evidence as normal with my data, showing a mass that decreased. But then when I get to my reasoning, I'm going to state that my lab data does not align with scientific research. And I'm going to give a potential reason why, what I might have done wrong. Then we'll state the expected answer just like I did before. Okay, so this yellow part I added in, for example. So our lab data did not align with what you would expect to see take place. We believe this was due to human error because when we weighed the steel wool initially, we forgot to zero the scale. Okay, so that would make the mass more than it's supposed to be. When we were ready to burn the steel wool, we removed it and placed it back onto the scale, but this time we did zero the scale. Okay, this means that our initial mass was most likely incorrect. We would expect to see the mass increase after burning. And then I explain why. Okay, so refer back to this if you end up doing a lab and you don't get the results you think you should have. So hope this was helpful. And that's all we got here.